Imagine this, you're a helicopter pilot in trouble. Engine is failing and you're going down fast. In a fighter jet, you'd pull the ejection handle and rocket to safety. But in a helicopter, that's a whole different story. Massive rotor blades spinning directly above your head at blistering speeds. So the big question is, can a pilot eject without being shredded by those blades? And the answer is yes. But one of the methods is so wild it sounds like science fiction until you see it. Before we get there, let's clear up some common ideas. You might be wondering, if the rotors are spinning overhead, why not eject downward, sideways, or forward? Let's start with downward ejection. Helicopters typically operate close to the ground, valley floors, rooftops, and treetops. Parachutes need space and time to open. Firing the seat down instantly spends what little altitude you have, making the downward ejection practically useless. The pilot can hit the ground in about a second, long before the parachute opens. On top of that, a hard push downward creates negative Gs, driving blood into the head, causing red out, hemorrhaging, and potentially fatal head injuries. Now, sideways ejection. A violent sideways ejection could cause severe internal injuries and puts huge load on the neck and spine. Without specialized head support, the head can whip sideways, risking a broken neck. Next, forward ejection. Forward ejection is blocked by the helicopter itself. You have the whole front of the helicopter in front of you. A forward launch seat would need a horizontal rail and a much stronger rocket to launch the seat ahead of a still-moving helicopter. So we're left with vertical ejection upward, and that is how ejection seats are designed, because acceleration along the spine is what humans tolerate best. But there's a catch. You still need to clear the rotor first. Russia came up with a bold way to eject from a helicopter. The Ka-50 Black Shark and the newer two-seater Ka-52 Alligator use a fast, step-by-step escape. They're the first and still the only helicopters in the world equipped with actual ejection seats. First, explosive bolts in the rotor hub blow both sets of coaxial blades clear so nothing is above the cockpit. Next, the canopy is blown off. Then, a rocket-powered ejection seat launches the pilot up and out. That's a tractor ejection system because it pulls on you instead of pushing. Most ejection systems punch out the whole seat, then separate the occupant. Tractor systems leave the seat in the aircraft and drag the crew out by straps attached to their shoulders. Another way to land a helicopter safely during engine failure is called autorotation. Unlike Russian Black Shark and Alligator, most helicopters, especially US and European models, are designed to auto-rotate in emergency situations. Here's how autorotation works. When the engine stops, the pilot quickly lowers the collective, the lever that sets blade angle. That cuts drag and keeps the rotor spinning. As the helicopter comes down, air moves up through the blades and helps them keep turning. Near the ground, the pilot raises the nose to slow the drop, then lifts the collective to increase blade angle. That uses the rotor's spin to make extra lift and soften the landing. But auto-rotation does not always work. In 2014, an Apache crashed near Boise after both engines shut down. The pilots attempted auto-rotation at just 400 feet, far too low to recover. Tragically, both pilots were lost. You might ask, why don't US helicopters have ejection seats? Because ejection seats add weight, complexity, and cost. American helicopters focus on performance and efficiency. They're usually lighter and more advanced, which also makes them more expensive and harder to maintain. Russian helicopters focus on ruggedness and reliability. They're built for easy field repairs, which makes them simpler and less polished, but often better at surviving battle damage. And finally, what about outrunning the blades at very high speed? Here's the reality check. Even if we fantasize for a moment that an ejection seat could launch you to Mach 10, that's 7,672 miles per hour, or 3,430 meters per second. A 180 kilogram Pilot Plus seat would need roughly 2.5 million newtons of thrust and about 1.1 billion joules of energy, which is equivalent to 0.25 tons of TNT delivered in just a quarter second. This creates approximately 1,400 Gs of acceleration. And remember, normal humans can only survive up to 20 Gs. At that speed, air resistance hits like a solid wall. Also, parachutes can't even deploy at anywhere near these speeds. Forget about rotors. At 1,400 Gs, you'd be turned into human paste. If you could add one safety feature to keep the helicopter crew safe, what would it be? Feel free to share your thoughts in the comments below. If you found this video interesting, hit that subscribe button and turn on notifications for more explanations of the world around us. Thanks for watching.